Okay, we're going to do an illustration on interfaces and abstract classes. So I've got an interface here. Notice it looks similar to the class that we normally do, public class, whatever. This is called an interface. Okay, and the main difference right now is to understand that these method headers are abstract methods. They're public abstract methods. Now, what abstract means is that you're not going to supply the code here. You'll supply the code in a subclass, okay, or in a class that implements this. Okay, so right now you can understand that we just in general want a shape. It would not make sense to create a shape. You know, a shape doesn't really make sense until you define exactly what the shape is. So you cannot instantiate a shape if it's an interface, okay? But what it does is allows us to create a general skeleton for shapes. So basically any shape, we're going to be able to create the method of get area, get parameter. Now, they'll be different for every shape. So that's how this works. Okay, so first we have, make sure this compiles. Does, okay. So I have an interface shape. Now I'm just going to create two subclass or two class that implement shape. Now what it means to implement, let's do rectangle. So we've done some things with a rectangle before. Public class rectangle implements shape. Now if a class implements an interface, then you have to supply those methods. So like right now, I could go to compile. That's going to say you did not override get parameter. Also didn't override get area. Okay. So for a rectangle, we have a length and a width, and we have public double get area, and we return length times width. We also have a public double get perimeter, which would be return 2 times length plus 2 times width. That's a rectangle. Okay, and that's all I'm going to do right now. You could obviously have other methods that would go in the rectangle class. But that's all I'm going to do. Let me create another class called circle. Okay. Now a circle is not going to have the XY coordinate like I did in the other class. I'm just defining like a shape of a circle, so I'm only going to have a radius. How big the circle is. It's irrelevant where we put the circle. It'll be private int radius. And just like rectangles, I've defined the radius to be an integer. It could be a double. Okay, so let's do, I also need to go back and do a constructor for the rectangle class. Let me just do this one. Public circle takes in an integer. Remember that this is a constructor. The main purpose of a constructor is to initialize the fields. So now this would allow me, that's important. That's kind of the whole purpose of this thing. Now this will allow me to create a circle with a given radius. Okay. So I also need to, and notice if I compile, it's going to say you did not override those methods. Okay. So public double get area. The area of a circle is pi times radius times the radius. Now R only makes sense in this, between these braces. Radius is the field. That's the scope is from there to there. Okay, and then we have public double get perimeter. And the perimeter of a circle, or sometimes called circumference, just the distance around the circle, is 2 times math.pi times radius, 2 pi r, which you probably heard before. All right, so now I have 2 classes that implement the shape interface. Let me go back and do one thing, and I'm going to do the initialize constructor here for rectangle. That'd be public rectangle. Notice I'm not doing a default. That's not what I'm focusing on here. The focus of this video is interfaces and abstract classes. Okay. So that's how that works. Okay. So we have to go back to the interface. Both of these, both of the classes that implemented shape had an area and a perimeter. So this is just an interface called shape. Now, in the next video, I don't think I'll have time in this one. In the next video, I'm going to show why interfaces are one of the main benefits of interfaces, why we even do them. Because right now, it might seem like we're just doing more work that we really need to. Why couldn't we just define the area and the perimeter in the other classes? And again, I'll show that in the next class period, or the next video. Now, one other thing I want to show you is in an interface, all of the methods have to be public abstract. You cannot supply the code for any of your methods. And by the way, this is understood. Let me see if that compiles real quick. Yeah, it does compile. That's what all of these methods are. If you just do the return type and the method name with whatever the parameters you need, it works. But it is technically a public abstract method. Now again, what an abstract method is, an abstract method is a method that you don't supply the code for. Okay, so that's an interface. And again, I hope I'll bring all this together. But the next thing is an abstract class. Now an abstract class is kind of one step down from an interface. It usually has some abstract methods, but not all of them. So basically, there's some things we want to kind of factor out that are common to all the classes that will go under it. But then there's also differences that we will supply in the actual classes that go under it. Okay, so this is an example. So let me change this to abstract class shape. Okay, notice this is good. Now I think I do have to say that these are abstract. Okay, let's see. Okay. Now, and I still want these to be abstract. And the reason I want them to be abstract, I don't want to supply the get area and the get perimeter methods in shape because they're going to be different in all the other classes, like rectangle and circle. Now, suppose I did have a method called, I wanted the ratio of the area and the perimeter. Well, that's the same for every shape. As long as you know what the area is and as long as you know what the perimeter is, then the ratio would be the same. So if there was a method like that, and this is a pretty general example, but if there was a method like that, that's going to be common to all shapes, then it would be better to use an abstract class and define that method in that class. So in this case, it would be public double. Notice it's not abstract. It's going to be the same for all classes. Get ratio of area to perimeter. I don't know why you would want to do that, but again, just illustrating the point here. So that would always be that for all shapes. If you're able to get your area and you're able to get your perimeter, the ratio of the area to the perimeter is these two things divided by each other. And that's the same. Okay? So the idea is an interface if all your methods are going to be abstract. Okay? But if there's a common method that it's going to be the same for all, in this case shapes, it would be better to do it as an abstract class and define that method in that class. Okay, now if it's an abstract class, is the last thing for this video. If it's an abstract class, then you do not use the word implements anymore. It would be extends, because it's a class and this is a subclass. Okay. One thing to notice, or one thing to know, is that a class can only extend one class, but it can implement several interfaces. Okay. So again, I'll pick this up in the next video and show you kind of why we use these things.